first time you try to find the antiderivative of tangent, it's a little complex. It will stump you, most likely. There's no obvious answer to this where you can just come up with some trig function whose derivative is tangent. I know the derivative of tangent is secant squared, but I don't know a function whose derivative is tangent. But I can rewrite tangent as sine over cosine. I know I can do that. And it turns out that this simple algebraic rewriting of tangent is enough to point me in the right direction for finding this antiderivative, because now if I let u equal cosine of x, then the derivative of u will be negative sine x, which will handle this numerator. And so I'll be left with negative 1 over u du, and I know how to find the antiderivative of negative 1 over u. So I'm going to let u equal cosine x. I'll go ahead and write out the u substitution that I was talking about. I know that derivative is negative sine. I'll solve for dx, treating dx and du as variables. So multiply both sides by dx, divide by negative sine. Plug that in for dx here. I'm going to rewrite cosine as u. I wrote this incorrectly. I should have been dividing du by negative sine x. It's important for me here because that sine x in the bottom should be canceling this sine x. Alright, now these do indeed cancel. So I'm left with the integral of negative 1 over u du. I know that the derivative of natural log of x is 1 over x. So this antiderivative is negative natural log of u. Plus an arbitrary constant. Now I'll go back and plug in what u was. I'll include the absolute value around that u. And then sometimes you'll see this solution written as natural log of 1 over cosine, natural log of the absolute value of secant. Because of the power rule with logarithms, you can bring this negative 1 as a power on cosine. So this could be written natural log absolute value of 1 over cosine x. Either one of those is good. You can do something similar with cotangent. You rewrite cotangent as cosine over sine. You can use a u substitution to figure that one out. You can even do secant and cosecant, but those require an additional little algebraic manipulation that you wouldn't think of immediately.